This is a review of the first question in Exam 4. The first question is multiple choice, conceptual. Show work for partial credit. In Part A, in the figure, a cart's change of momentum is asked for. Initially, the cart is moving to the left, which means its velocity is minus 2 meters per second. So it's a momentum at that time, P initial. Is equal to its mass, which is 10 kilograms, times its velocity, which is minus 2 meters per second. And then later, its momentum, P final, is equal to the same mass, 10 kilograms, times plus 1 meter per second. So the change in the momentum is equal to P final minus P initial, which is equal to the mass times the final velocity, 1, minus the initial velocity, which is minus 2. So we have 1 plus 2, or 3 times 10. And the answer is 30 kilogram meters per second. In Part B, a light plastic cart and a heavy steel cart are both pushed with the same force for 1.0 seconds, starting from rest. After the force is removed, the momentum of the light plastic cart is blank that of the heavy steel cart. Well, in this example, the change in the momentum, which is defined as the impulse, or the average force times the time interval, is the same for each case. So the momentum of the light plastic cart is equal to that of the heavy steel cart. In Part C, the fan blade is speeding up. What are the signs of omega and alpha? Well, the sign of omega is negative because the sense of the rotation is clockwise. The direction is clockwise, and whenever it's clockwise, then that is a negative rotation, and the angular velocity is negative. And since the fan blade is speeding up, the sign of alpha must be the same as the sign of omega. So alpha's sign is negative as well. The correct answer is choice 4. In Part D, 3 stars are aligned in a row. The net force on the star of mass 2m is what? Well, the force on the 2m mass due to the 5m mass over to the left of it is proportional to the mass of the big body, which is 5 times m, over times the mass of the middle body, 2m, over their distance, which is 4 units squared. So that gives you a ratio of 10 to 16. The force on the 2m mass due to the mass on the right is proportional to the mass on the right, which is 1, times the mass in the middle, which is 2, over the distance of separation, which is 2 squared. And that yields a ratio of 8 to 16. So the force on the left is greater than the force on the right, and then the net force must be to the left. And that concludes this video.